Okay, so we're going to start with a fairly simple exercise that has to do with the right angle triangle, and we know the values of this side and this side, but we have to figure out those values over there. So let's start with C, which is the value of the hypotenuse. We can just use the Pythagoras theorem over here. So I'm just going to plug in those values. We know that our A is equal to 6 and our B is equal to 8. But of course, this value here is for C squared, so now we have to do the square root of that. Which is just equal to 10. So I'm just going to put that value over here. And I'll erase this to make more space. Alright, now we're going to look at the angles. So for that, we're going to use these formulas over here. And again, I'm just going to plug in the numbers. So we'll start with alpha. We know that our A is going to be 6, and now I know that the C hypotenuse is going to be 10. So don't forget that that is the value for cos of alpha, but we actually want the value for alpha. So and then you would plug this into a calculator and it will give you the value of the angle. And now we're just going to do the same for cos of beta, which is this angle over here. And this will give you the value of the degree. So this is a similar problem with the right angle triangle, except we're trying to figure out slightly different values, and we are given the value of alpha instead. So first, for example, we can look at the value of beta. So we know that all these angles together are going to be 180 degrees, and we also know that this angle right here is 90 degrees. So we know that these two together are going to be 90 degrees, therefore we can just think of it like this. So we know that our alpha is 30 degrees, so our beta is going to be 60 according to this. So yeah, that's the first part. I'm just going to write it here so I can erase it. So for the second step, we're going to look at the sides. I'm going to start with C, the hypotenuse, and for that I'm going to use this formula over here. So we know that our A is equal to 3, and we want to figure out our C. So for this, I'm just going to rearrange it. We know that our alpha is equal to 30 degrees, so I'm also going to include that here. So cos of 30 degrees is actually equal to this. And by rearranging, you will get something like this, which will give you this value of C. And I'm also going to write that up here just so we can keep track and I can erase it. So now that we have our C, getting our B is actually going to be really easy because we only have one side left to calculate. We can just use the Pythagoras theorem like we did before. So we have our C to the power of 2, our A to the power of 2, and we want to find our B. And I'm already going to calculate the powers. This is just going to be equal to this, which means that if you do the square root to get B, you just get square root of 3. So this is the value of your B, and you can finish the last step of the exercise. So in this third trig exercise, we're going to go from degrees to radians, and we've got 270 degrees here, and as we know, going from here to here is 90 degrees, then from here 180 degrees, and this part right here marks our 270 degrees. But how do we know how many radians that is? So we know that 180 degrees is equal to pi radians. And just this allows us to do some calculations to know how many radians 270 degrees is going to be. So here we just divided by 180, and now we're going to go to 270 degrees. Now if you divide this, what you get is 3 over 2 pi radians. Now, as I said in the beginning, 270 degrees corresponds to this point over here, and this is also going to make sense with the 3 over 2 pi radians, because we know that when you go from here to here, you have pi over 2. Then from here you have pi, which corresponds to 180 degrees, and then down here 3 over 2 pi, which is then 270 degrees.